we're going to start off Unit 5 talking about perpendicular bisectors. So super important concept here. And a perpendicular bisector can be either a line, which goes on forever in either direction, a line segment, which starts and stops, or a ray, which starts and then goes on forever in one direction. So a perpendicular bisector could be either one of those. What has to happen for it to be a perpendicular bisector is that it has to be perpendicular to a segment. So let's let this be our segment. I'm going to pick a line for our perpendicular bisector. So these two would have to be perpendicular at right angles to each other. And that line would have to go through the midpoint of that line segment. So if it goes through the midpoint, that means this piece is equal to this piece. So this would be our perpendicular bisector because it's perpendicular to the line segment and it cuts through the midpoint. So that leads us to a couple theorems that we have with the perpendicular bisector. The first one is the perpendicular bisector theorem. It says, if a point is on the perpendicular bisector of a segment. So let's go with this. We've got a point. We've got a point on the perpendicular bisector. Then what's true is that that point is equidistant from the endpoints of the segment. So that point that we drew on the perpendicular bisector is equidistant, which means the same distance from either end of the segment. I'm going to try to make that a little straighter. It is kind of hard with the stylus. Not much better. But if that were a line segment, that would be equal to this side. So these two black line segments would be equal. So to repeat, we've got a point on our perpendicular bisector. That point is automatically equidistant from the two endpoints of the line segment. Equidistant meaning same length, equal distance. So that's the perpendicular bisector theorem. Let's look at the converse of the perpendicular bisector theorem, which says if a point is equidistant from the endpoints of a segment. So here's a point, here's a line segment. It is equidistant from either ends of this line segment. So that means this is equal to this distance. Those should be straight lines. So if a point is equidistant, then that point is on the perpendicular bisector. So we could draw our perpendicular bisector in, and then we would know, because that is the perpendicular bisector, that that is bisecting this segment down here. So each of these pieces is equal. So this piece and this piece are equal. So we've got the perpendicular bisector theorem and the converse of the perpendicular bisector theorem. Let's go ahead and work a couple problems here. All right, in example 1, it's asking us to find the measure of FM. It tells us that FK, that means line segment FK with the line over it like that, FK is the perpendicular bisector of GM. So automatically, since FK is the perpendicular bisector, we know that this angle is a right angle, which it shows us already, and GK is equal to KM. So if that's true, FK is the perpendicular bisector, then we know this point at the top, F, is equidistant from both G and M. So that means FG is 2.8, and that means FM is 2.8. So we can say FM is equal to 2.8. In example 2, it tells us that BD is the perpendicular bisector of AC. So automatically that tells us two things. that tells us that this angle is a right angle, and it tells us that AD is equal to DC. So AD equals DC. So if those two are equal, we can set these two expressions equal to each other. So we can say 5x minus 6 is equal to 3x plus 8. And if we solve that equation for x, we get 2x minus 6 equals 8, or 2x equals plus 6 plus 6, 14. And then we can divide, and we know x is equal to 7. So that's how you can work problems using those two theorems.